Okay, so let's put our algebra skills to the test and see if we can solve this beast. It's complicated, but we pretty much follow the same procedure as before, so I think we could do it. The first step is to isolate one of our temperature expressions. And I think it's easiest to start with the balance equation for our second layer of atmosphere because it already isolates our term for T1 in terms of an expression with T2. This means that we could substitute the right hand of this equation into the other two equations wherever we see sigma T1 to the fourth power. We can go ahead and do this by substituting into our equation for the first layer of atmosphere. If we substitute into the right-hand side of the equation, we have 2 times the expression that we will be substituting, which means that we will have 2 times sigma T2 to the fourth on the right-hand side of the equation. If we distribute the 2 inside the set of parentheses, we can see that we will end up with 4 sigma T2 to the fourth. Our equation becomes sigma Te to the fourth plus sigma T2 to the fourth equals 4 sigma T2 to the fourth. We can continue to simplify this equation by subtracting sigma T2 to the fourth from both sides, leaving us with sigma Te to the fourth is equal to 3 sigma T2 to the fourth. This is great because now we have an expression that we could use to substitute in for terms containing the Earth temperature. Actually, you'll see that we can express our third equation for the Earth stock purely in terms of T2 because we can substitute 3 sigma T2 to the fourth for sigma Te to the fourth, and we can substitute 2 sigma T2 to the fourth for sigma T1 to the fourth. Let's go ahead and do this. Carrying out the substitutions, we get omega over 4 minus a omega over 4 plus 2 sigma T2 to the fourth equals 3 sigma T2 to the fourth. My next step is to subtract 2 sigma T2 to the fourth from both sides in order to get omega over 4 minus a omega over 4 equals sigma T2 to the fourth. This is actually an equation that we've solved before. And if we wanted to, we could solve for T2 and find that it's equal to roughly 255 degrees Kelvin. So very cold temperature. More importantly, we have a result that we can substitute back in to find the temperature of the Earth stock. If we substitute in omega over 4 minus a omega over 4 for sigma T2 to the fourth, we'd be able to find that sigma Te to the fourth equals 3 times omega over 4 minus a omega over 4. At this point, we know how to solve this. Te is equal to 3 over sigma times omega over 4 minus a omega over 4 inside a set of parentheses, all raised to the 1/4 power. Plugging this into a calculator, we could find that Te is 336 degrees Kelvin, which is over 140 degrees Fahrenheit, which is pretty much the hottest temperature humans have ever recorded on this planet. So it's probably not a great estimate of the average global temperature. So this tells us that we have some work to do to improve our climate model. And even though our numbers are getting wackier, I promise you that our climate model is actually getting closer to a very accurate climate model that we can use to estimate accurate future temperature predictions. So if we wanted to, we could also solve for the temperature of the lower layer of atmosphere by substituting omega over 4 minus a omega over 4 into our very first relationship for T1. If we do this, we will find a familiar number for the climate model, which is 303 degrees Kelvin. So basically, the lower layer of the atmosphere is now the same temperature that the Earth was in the one layer model, and the upper layer of atmosphere is the same temperature as the atmosphere was in the single layer model. The temperature of the Earth is now 30 degrees warmer than it was, which tells us that adding more greenhouse gases to the atmosphere does indeed increase the temperature of the Earth. And we all knew this, but it's kind of fun to see how this all works out in our stock and flow model. It gives us a really deep understanding of how this greenhouse effect is impacting conditions here on Earth.